Good evening and welcome to part 3 of the first lesson of probability, the binomial distribution, with me, Mr. Sutton. What we're going to just talk about to start with is the 4 conditions that have to be met for us to be allowed to use the binomial distribution. Well, firstly, as the name implies, by 2, there have to be 2 possible outcomes, and I've talked throughout this first lesson of success or failure. Yes or no, win or lose, there's 2 outcomes. If there's more than 2 outcomes, it's not binomial. The probability of success has to be constant. So in the previous example, we were taking out counters and then we were putting them back, and that was keeping the probability the same. If we had taken the counters out and not put them back, that would have changed the probability, and therefore we wouldn't be allowed to use the binomial distribution. So probability has to remain constant throughout. There have to be a fixed number of trials, so in the previous one we said we did it 4 times, and that has to be consistent, and each trial has to be independent of previous ones, so there has to be no effect on the probability of what you've done before. So for example, a die is quite a good example of when you could use a binomial distribution. An example of when you might not use a binomial distribution, if you think about throwing a dart at a dartboard and thinking about the probability of hitting a bullseye, you would expect that over a period of goes you'd get better at that, and therefore your probability is not staying consistent, because each result is not independent of the other, because you're getting better as you're practicing. Anyway, the purpose of this is to look at, if we're given a distribution such as this, the random variable x follows the binomial 7, 0.3, can we find the probability of 4 successes without having to go through the whole rigmarole of working out the probability of 0, 1, 2, 3 like we did in the previous one? And the answer is yes. It's very straightforward, because we just say we know n and we know p, because that's what we've got as our distribution. So in part A here, the probability of x being 4, that's getting exactly 4 successes. So the way we would do that, we would say, okay, we're doing it 7 times, and we're succeeding on 4 occasions. So out of 7 goes, how many different ways could we win 4 times? How many different orders could that happen? That's what this calculation is going to tell me. Now, I'm winning 4 times, so my probability of winning is 0.3. It's going to happen 4 times, so 0.3 to the power of 4. Now, I'm going to lose 3 times. So if I win 4 times in 7, I'm going to lose 3 times. Now my probability of losing is 0.7, because these have to add up to 1. And the number of times that I lose has to be 3, because wins plus losses, or successes plus failures, has to equal the number of times I did the experiment, the number of attempts that I had. That goes into a calculator. 7 choose 4, using, on these class with shift divide, and then multiply it by 0.3 to the power of 4 times by 0.7 cubed, and we get 0.0972 to 4 decimal places, which is the standard amount of rounding that you do in these questions. So part B, probability that x equals 0. You may be thinking, why is he doing that? It's just the same with the numbers changed. Well, there is a specific reason for this. It's to do with no successes, and actually a quick way that you can work that out. We'll do it the proper notation way to start with. So 7 choose 0, we've got no successes, no wins. So our probability of success to the power of 0, and our probability of failure to the power of 7. Now, I'm going to break this one down a little bit, because 7 choose 0 is 1, 0.3 to the power of 0 is 1, so actually the only bit that's relevant to this calculation is the fact that I failed 7 times. So I can just work out what 0.7 to the power of 7 is, and that will tell me my result, which is 0.0824. Again, to 4 decimal places. This comes in very, very useful when we come to later on work this backwards. when we're being asked to find a probability given some information about outcomes and the probabilities of those outcomes happening. Generally we're given the chance that x equals 0, and we can use that to work backwards to find p. But more on that later on. Now with part C, the probability that x is less than or equal to 1, there is another way to do this on the calculators, but for now we're just considering what does that mean. Well, less than or equal to 1 means actually we want to know the probability of x equaling 0 and the probability of x equaling 1. So 0 or 1 successes would satisfy this condition. Now we have the probability that x equals 0 here, so I'm just going to store that answer in the calculator now so that I can use it later. And I'm actually just going to work out the probability of 1 success. So 7 trials, 1 success. Probability of success to the power of 1 times by probability of failure to the power of 6. So I'm going to put that in the calculator now. And that comes out as 0.2471 to 4 decimal places. I'm actually not going to round it at this stage because I'm now going to say that the probability that x is less than or equal to 1 is my stored answer that I've got from before plus this answer here, and rounding that to 4 decimal places we get 0.3294. Now, bonuses, your class whiz calculators will find this out for you using something called the binomial PD function. So what you need to do is you need to press the menu button and select number 7. That will take you to distributions, and it's then number 4, which is binomial PD. And this one finds you the probability of a specific number of successes. There is another function that will find you the probability of up to and including a certain number of successes. And what it asks you for when you do that is whether you want a list or variable. We'll go with variable on this one because we just want to get one result. The list function allows you to get lots of results and lists them, but we'll just do it this way for now. And it asks you for x, n and p. Now x is the number of successes, so if we do this for part A it would be 4. N is the number of trials, which we get from here, so 7, and p is the probability of success, which is 0.3, which we get here. And what I'm hoping is my calculator screen is now going to say 0.0972, which it does. Happy days. So this is the way that you would do it quickly using your calculator. However, it's important that you understand what it's actually doing in terms of the number of successes and the number of failures, so that you can apply that to more complex problems that we'll look at in a future video. Thank you very much.